Okay, so now we're going to do the opposite strategy. We're going to do passive bond management. So this is exactly the opposite in the sense that now we are not trying to guess the market. We are trying to play it safe. Okay, so we want to have a return that is known, fixed, okay, safe. Right, so this is useful, for example, in countries where people um, save for their retirements in private accounts. Okay, it's not very common here in Portugal, but in other countries where the social insurance scheme is different, people do this type of saving. So in those cases, insurance companies sell what is called a guaranteed investment contract. So it's as the name suggests, it's a product that guarantees a given return over a given period. So, for example, suppose I want to save money for 10 years and I want to know exactly how much is going to be my return. Okay, so the insurance company would sell me this guaranteed investment contract, and they would state that the rate of return over these 10 years would be, I don't know, 5%, something like that. Okay. So now let's look at the point of view of the insurance company. So when they sell this to me, they are basically selling a zero coupon bond. Okay, so they are going to have to invest their assets, the money that they charge me, in such a way that guarantees that 10 years from now they will have enough money to pay back that zero coupon bond, right? So what are the options that they have? Well, the ideal would be to invest in another 10-year zero coupon bond, okay? But that does not exist. That's why we have this problem in the first place. There is not such a long-term zero coupon bond. So the insurance company will either have to invest in bonds that are short-term, say 5-year bonds, and in that case, there is reinvestment risk. When it gets to the end of the 5 years, it has to reinvest for another set of years until it gets to the terminal 10-year date. So the rates on the market at that future moment are not known, so there is risk. Alternatively, the insurance company could invest in longer term bonds, say bonds 15 years, 20 years, and so on. And in that case, there is price risk because we don't know at which price we'll be able to sell the bonds when we get to the 10 years. And in addition, there is also reinvestment risk of the intermediate coupons. So there is no simple solution to this problem. Okay, so that's where this immunization strategy comes in. Okay, so what is an immunization strategy? Okay, it's an investment strategy that has the goal to build an asset portfolio that does exactly what I just described. It means that guarantees that we'll be able to pay the liabilities at a given moment in time, right? And the important thing is that we are going to be able to guarantee that we have enough money in the future, 10 years from now, regardless of what happens to interest rates in the meantime. So until 10 years from now. All right. Okay, so the goal is clear. We want to make sure that we have enough money to pay the liability. We again are the insurance company. Okay. So how exactly do we do that? So the rule for the immunization strategy is very simple. Just these two rules, two steps that you see here. So the first rule basically just says that the present value of the assets has to equal the present value of the liabilities. So what does that mean? It means that I have to fully fund the liabilities. Okay. And then the second one, which is the one that is not so obvious, is exactly how I build the portfolio of assets. So what the rule says is that I have to build a portfolio of assets such that the duration of that portfolio of assets is equal to the duration of my liabilities. So in this example I was just describing, I have a liability that was a zero coupon bond with a maturity of 10 years. Therefore, the duration is 10 years. And what the rule is saying is that I have to invest in assets such that the duration of that portfolio is also 10 years. Okay. So let's see this with a simple example. Okay. All right. So we want to immunize a liability of $1 million during 2 years. Okay. And we have the following two assets in which we can invest. We have a 1-year zero coupon bond. Okay, it's too short, but as usual, zero coupon bonds do not stretch out to very long maturities, so that's the usual case. And then we also, an alternative, we have a coupon-bearing bond that pays 5% annual coupons, but has a maturity after the liability. So it has a maturity of 3 years, right? So it's a very simple example, but that illustrates this problem that I just described happens in reality, okay? Let's assume that the term structure is flat at 5% with continuous compounding. Okay, so let's go through the steps of how we implement the rule. Again, 2 steps. We want to find the present value of the assets to fully fund the liabilities, and then define the weights of the portfolio. Okay, so let me open the figure here. Okay. So again, these are the timelines. The liability due in 2 years, 1 million. These are 2 possible assets: a zero coupon bond with 1 year to maturity, and then a coupon-bearing bond with 3 years. Okay. All right. So the first rule was the present value of the assets has to equal the present value of the liabilities. The present value of the liabilities is just the present value of this $1 million discounted back to time 0, and we were assuming that interest rate was 5% with continuous compounding. Okay. So that's the amount we need to charge the client, right? We insurance company are going to ask this amount of money. We actually are going to ask a little bit more, and the difference is the profit of the insurance company, okay? All right, so rule number 2. We now want to determine the weights that we're going to put in each of these 2 assets such that the duration of the portfolio equals the duration of the liability, right? So let's compute the duration. So first we have to compute the price of the zero coupon bond, just the present value of 1. The duration is 1, just the time until maturity. And then for the coupon-bearing bond, again, the usual thing, the price is the present value of these cash flows that you see here. And then the duration, using the formulas we have seen before, is just given by this, and it's 285.91 years, okay? Now, the rule states that the duration of the assets has to equal the duration of the liabilities. And the duration of the liabilities, it's obviously, this is a zero coupon bond, so the duration is obviously 2 years, okay? So the duration of the liability of the assets has to be equal to 2. Okay, so since we have 2 assets, that is going to imply this linear system of 2 equations in 2 unknowns. So the unknowns are the weights that I'm going to put in each asset, in the zero and in the coupon bond. This is the formula for the duration of a portfolio. It's the weighted average of the individual durations, and I'm saying that this has to equal 2, right? Which was what I just said here, okay? And also the weights have to add up to 1, all right? So solving these 2 equations into unknowns, I get these weights that you see here, right? So 46% of the money has to go to the zero, and 54% has to go to the coupon bond, okay? So finally, just an additional step that is going to be useful later on. We need to figure out exactly how much face value, how much quantity of each bond we're going to buy, okay? So recall that the face value is related to the actual investment through this usual equation that we have seen before, okay? Investment equals price times face value. So I'm going to determine the face value for each of the assets. So the face value for the zero is the amount of money that I'm going to put in the zero. So it's the weight that comes from here times the present value of the assets that we found here, 904,000, okay? And divide that by the price of the zero that you also computed before. And that gives me the face value that I'm going to invest in the zero coupon bond, okay? And likewise, for the other bond, for the coupon bearing bond, I determine the face value, okay? And that's it. That's the rule. That tells me that how should I invest in these 2 assets such that I am guaranteed to have enough money to pay the liability in 2 years, right? Okay, so this table summarizes these values that we just computed. And so now an important remark. So this will work under these following assumptions, okay? So first one, we assume that the change in interest rate is very small and parallel, okay? we assume that this change in interest rate happens right now. So I invest in the assets, and 1 second after this, interest rates change. And number 3, we assume that interest rates do not change after that. And by not changing, I do not mean that they will be the same number ever after. I mean that they will evolve according to the forward rates that we see in the market right now. Okay, so what we see now as forward rates is what will become the spot rate when we get to that moment in the future. Okay, so obviously these are very restrictive assumptions. We will take care of this and generalize the model later on. Okay, but for now, let's just see that this does work under these assumptions. Okay, so example 342. So let's assume that immediately after doing what we just did in the previous example, so after setting up the portfolio, interest rates change. Okay, so let's say, for example, that they increase by 40 basis points. Okay, immediately after setting up the portfolio, and after that they remain constant. So in this case, I'm actually assuming a flat term structure. So the forward rates are always the same. Everything is the spot, the forward, everything is just the same to make calculations easier. So everything will remain at 5.4, which was the previous 5, plus this additional 0.4. Okay. Okay, so what's the goal? We want to verify that the immunization strategy works, meaning we want to verify that when we get to 2 years from now, we have enough money to pay the liability. Okay, so let's do these calculations. Go back to the figure. Okay, this one. All right, so what are we going to do? First asset, zero coupon bond. We started at time 0. We bought the bond. Immediately after that, interest rates changed to 5.4 and then remain at 5.4. So then time moves forward and we get to 1 year. Okay. When we get to 1 year, the zero coupon bond reaches maturity and we receive the face value. Okay. So we receive this amount of money that we determined in the previous example. Well, I don't need the money now because the liability is only due 1 year from then. Okay. So I'm going to reinvest it for an additional year. At what rate? At the rate that is on the market right now. By assumption, we are saying interest rates remain at 5.4 forever. So when I get there, it's still 5.4. Okay, so I reinvest at 5.4 as you see here. So the total value that I have in the end is this amount of money compounded for 1 year at 5.4. And this is the total that I get at time 2, 463,972. Okay, the other bond, the coupon bearing bond. Again, the same thing. I buy the bond at time 0, interest rates change, and then nothing more happens. Time just moves forward. At time 1, I get the coupon. How much is the coupon? It's 5%, the coupon rate, times the face value that I purchased, which was determined in the previous example. Again, I don't need this money, so I reinvest it for 1 year at the interest rate in the market right then, which is the same 5.4%. So this will compound 1 year at 5.4%. I keep going in time and so on until I get to moment 2. Okay, so what happens at moment 2? I receive another coupon. Okay, this one here. And now it's the time that I have to pay the liability. So I am going to sell the bond, this coupon bearing bond that still has 1 more year until maturity, right? At what price will I be able to sell the bond? At its market price, which will the market price be? As always, the present value of future cash flows. Well, the future cash flows are this here. And the discount rate is the 5.4 that I am assuming will be on the market forever. Okay, so I discount the future cash flows at 5.4, and this is the market price of the bond. Okay, so I'm going to sell it for this price. So at this moment here, at time 2, from this asset, this coupon bearing bond, the total amount of money that I get is the coupon that is received now, the coupon that was received 1 year ago and that was reinvested, and the sale price of the bond right now. So the sum of these 3 numbers gives me this. So replacing the face value by the face value we determined in the previous problem gives me the total value of the bond at time 2, which is $536,036. Okay. So altogether, considering the coupon bond and the zero coupon bond, the total amount of assets that I have in time 2, the sum of these two numbers, this one and this one, is 1,000,008. And this is more than what I have to pay, the 1 million of the liability. So this worked, right? So that was the goal. I made an investment strategy that guaranteed an amount enough to pay the liability. Okay. Excuse me. So let's try to understand what's going on. Why did the strategy worked? Okay. So let's go back again to the images. So here's the idea. What I'm plotting here in the first figure is the value of the assets as we move through time. So from today, time 0, until the relevant date, which is 2 years from now, which was the duration of the liabilities. Okay. So the first black line here in the middle is the case where interest rates do not change. Okay. So I start with the initial investment that we determined, which was just the present value of 1 million. And therefore, if interest rates do not change, I will increase the value of the portfolio until I reach exactly 1 million in 2 years. Okay. So again, this is the case where interest rates remain at 5% the whole time. There is no change. In this last example that we saw, what we did was we increased interest rates. So interest rates were at 5 and then they jumped to 5.4. Okay. So what's the effect there? There are two effects working in opposite directions. One first effect is that if interest rates go up, immediately you see a drop in price because there's this inverse relation between prices and interest rates. If interest rates go up, bond prices go down. Okay, so that's the first effect. The second effect is the good one, meaning if interest rates go up, then the reinvestment rate in the future is also higher. Okay, so that will make the portfolio grow at a faster rate. Okay, so even though it comes down, then it goes quicker up. It accelerates. It goes. It is steeper on the way up. Okay, and it so happens that when we get to time 2, the red line is also above 1 million. Okay, so if interest rates go up, this is exactly the moment in time when we reach at least 1 million. Okay. Suppose the opposite scenario happens. So immediately after setting up the portfolio, interest rates moved, but in the other direction. They went down. Okay, so they were at 5. Let's say they went down to 4%, for example. So what's the effect? Again, two opposite effects. The first effect is that when interest rates go down, bond prices go up. So the portfolio value will jump from here to here. Okay. But then the second effect is bad in the sense that if interest rates went down, then the reinvestment rate is also lower. So the portfolio will grow at a lower rate. So the line does not grow as quickly as the previous cases. But since it started at a higher point, it is still enough to reach the 1 million by year 2. Okay, so in all cases, we get enough money at year 2. Okay, so if we actually focus on what's going on here at this point, this is what this second figure here does. Okay, so we are plotting the value of the assets at this moment in time. So this value here at moment 2, depending on the interest rate. Okay, on the new interest rate or on the changing of the interest rate, if you want. So the case where interest rates stay at 5% again is the case, so they don't change, is the case that when I get to time 2, I have exactly 1 million. It's this black line at this point here, exactly 1 million. Now, if interest rates go up to 5.4, which was the example we did, what we see is that we get to the end with a little bit more, 1,000,008, right? If we did an example for some other number in the other direction, 4%. You may try this later on. If you do everything as we did, but with a change in interest rate of 4%, you would find that at the end of the 2 years, you would also get a value higher than 1 million, so somewhere around here. So regardless of interest rates changing in the up direction or in the down direction, we are always guaranteed to have at least $1 million. Okay. All right, I'll stop here.